Developers build the future. We take ideas and make them real. My job is to think, create, and solve for a living.
Each step we take is possible because someone asked the questions. Why do we have to do it this way? What if we did it that way?
Each step I take enables people to go further.
Be creative, change something. I'm working on blockchain that will change asset identity.
Artificial intelligence to automate homes.
Autonomous robots to improve efficiency.
My app is advancing human rights.
I build things to help connect people. Not everyone gets to build their passion. We share what we know. We share what we do.
You try, learn, try again.
Make, break, build.
Every great startup begins with a simple idea. But with growth comes complexity. That's why so many innovators are on the IBM cloud, like Refinery29 with nearly 1 billion views a year, or Runkeeper, a training app used by over 50 million runners, or game developers, whose popularity depends on launching new updates fast. Helping to keep a company's success uncomplicated, that's what the IBM cloud is built for.
Ladies and gentlemen, please welcome Pratik Patel and Mary Grigleski.
All right.
Hello.
Oh, it's great to see so many friends. I see we have the NL Jug Posse over here.
Yay!
So great to be back at Java 1 again. You know, it's
That's right. Wait, we are at Oracle Code 1.
right,
That's
not
a new
Java 1.
Keynote.
I keep calling that all week, and I'm
That's
like,
right.
I need to somehow
That's right.
remember to not keep calling it Java
That's
1
right,
over
Java
and
1,
over.
that's
But
right.
anyways,
Yep.
So IBM is proud to be a member of the open source and Java community. We have lots of great stuff we're going to show you in the keynote in the next few minutes. We're going to get into mostly about how is our field of Java changing in cloud, AI, and other things that are coming into the fold with how we develop applications. So before we get to that, I just want to tell you all about a great community effort that we're doing at IBM.
Okay. So Call for Code began off the premise of demonstrating how the 22 million developers around the world could solve some of the world's greatest problems. As part of Call for Code, 100,000 developers from 156 nations created 2,500 applications around disaster preparations. On Monday, October 29th, we celebrate the developers that contributed over the past 4 months, as well as the final 5. You can use the link to register to watch the live stream, or the opportunity to join us at the Regency Ballroom. Call for Code is a multi-year initiative, so stay tuned to see what challenge will be the focus of the 2019 Global Challenge.
All right, thank you, Mary. So let's go ahead and get started. I'd like to bring on, actually, we'll do that in just a second. So as I said before, what we do as Java developers has changed dramatically over the last few years. We have cloud infrastructure that we use to deploy applications. Now machine learning and artificial intelligence is starting to come into the fold. So as the years have gone by, right, a long time Java development was pretty straightforward. You know,
That's
Mary,
right, yes.
basically wrote some servlets, maybe did a little EE.
That's right.
And now we have all these other tools that we use today. And that's what we're going to talk about. So our question is, as we evolve as Java developers, what is it that we have to keep up with? And what are the things that we need to know to be successful in the future? So I'd like to bring up John and Tim, and we're going to have a discussion around this.
Okay.
Yeah. John and Tim, please come to the stage.
Yeah.
Welcome, gentlemen.
We're ready.
You ready?
Yeah.
Yeah.
We were.
Well, we were doing whiskey shots in the back, so this may or may not go so well. Okay. Anyways. So, as you heard me tell the audience, we have a new set of challenges with the cloud and other things that we are bringing into the overall development flow. So, what are some of your thoughts on it?
Next jump. Chart. Well, actually, it's a pretty exciting time in Java space, actually in the runtime space, because as we move to cloud, there are multiple levels of innovation and areas of change. We have lots of stuff going on in the JVM we're going to talk about today. We have lots of interesting things happening in frameworks, the standard frameworks and beyond. And we have lots of interesting things happening all the way in an end-to-end story for cloud development.
Yeah, but cloud is a big term. It means different things to different people. And people are at different stages of their journey into embracing the cloud technologies. There are people that just use cloud like infrastructure as a service. They want to lift and shift their existing applications and just run them in the cloud. Other people are on a sort of app modernization play where you take your application into the cloud and then start to decompose it into microservices and other exposing capabilities of your application. And then, of course, there are the guys that actually build cloud-native applications directly in the cloud. But cloud is a reality for today. Whether it's time to move your stuff out into a public cloud or not, a lot of people want that sort of technology. So they're bringing cloud private technology in-house and using that sort of characteristic inside. So the JVM has to be able to exploit the characteristics of the cloud and use some of those characteristics as well.
Nice. So what you're saying is I shouldn't just use my IBM Cloud developer credits to mine Bitcoin. It's actually useful for other things too. All right.
It's been tried.
It's been tried. All right. So what we're going to do now is we're going to bring up some folks from the community to help us explore some of that a bit more. Okay.
Okay.
So let's bring up David, Mark, Ian, and Will, and talk about our IBM and the community contributions into the Eclipse Foundation.
Well done, guys.
We always get it wrong.
All right. Welcome, gentlemen. So we know all the high-level things that are going on in the Jakarta and EE space right now. But let's get an update. What's currently the status of Jakarta EE and some of the things that are happening in the EE space right now?
Well, we've made a lot of progress in the past year. We have sponsorship. There's the four of us plus Fujitsu and Payara who are sponsoring the initiative. We've got a place to do work at the Eclipse Foundation. We've built a community of over 200 committers. We've created a lot of source code, or we've contributed a lot of source code. Over 7.7 million lines of Glassfish code have been contributed to 88 repositories in 39 projects at the Eclipse Foundation. We've got a specification process in draft form for evolving the technologies in the future, and a very active community encouraging us to take specific technical directions.
Yeah. I think I would add to that the single biggest milestone in our 20-year history of standards is the open sourcing of the EE-TCK to the public, right? So the significance of this is that in the past 20 years, if you had an issue with portability, you could rightfully complain that you weren't getting delivered what was promised on the label. Over the next 20 years, you can't really do that because those are all open source and you can contribute tests to fill those holes in the portability gaps. So that is like the single biggest business advantage that you could possibly hope for, basically leverage over all the vendors who implement it, guaranteeing your own portability. So I think that we need to understand the significance of it and absolutely take advantage of it.
Yep. So that's what the current state of EE is right now. What's happening in the future? What's going to happen over the next few months, over the next 6 months, year or so, till we're back here next year?
Sure. Well, I think to look at what's going to happen over the next 6 months, the next year, I think you have to look at what's on the board, on the screen, underneath Jakarta EE at the moment. The group of people working in Jakarta EE are, broadly speaking, largely also working in the microprofile community in Eclipse. We talked at this keynote about microprofile last year, and it is focused on making it easier for Java developers to build cloud-native Java applications using standard specifications for doing things like having the container manage the injection of configuration into an application, perhaps running in a Docker container, from a variety of different config sources, enabling the container to help applications provide fault tolerance within their application so that the container can manage retries or handing over to application-provided fault handlers, for example. Enabling the container to expose an application's health point for a cloud platform to understand whether that application, again, perhaps running in a container, is healthy or not. These are kind of technologies that we've been building now in MicroProfile for about 2 years. We've been releasing MicroProfile, 7 times over the last 2 years. So in terms of what's coming next in Jakarta EE, a good clue is to see what we've already done in MicroProfile, because we expect MicroProfile to be the future of Jakarta EE.
Yeah, I'll just add to that. We've already heard from Ian about fault tolerance. There are a lot of things that we're doing in MicroProfile that are kind of leading the way for Jakarta EE. And we've released a number of things very, very quickly that we've not even attempted to do in Java EE in the past. And now we're seeing a lot of interest in things like reactive programming, asynchronous, and even starting to have talks about serverless, how we integrate MicroProfile and hence Jakarta EE into like Istio, make it a better citizen in Kubernetes. So a lot of things that are going on in MicroProfile that are kind of driving where I hope we will go with Jakarta EE in the future.
Okay. Thanks for the update, guys. That's great.
Okay.
Thank you.
Thank you so much.
Thanks. Let's give these guys a round of applause.
Let's have it. Let's go. No, we go off that way.
On the way.
All right, so as you heard these folks say, there's a lot of great stuff going on in the EE world, and the ball is being moved forward slowly but steadily, I think is a good way to put it. And one thing that Ian mentioned was cloud native, right? And everyone is probably aware of what cloud native is already, but let's dive a little bit deeper into that and see what the story that, we have the story around EE and MicroProfile, but what else is happening in the Java space with things like cloud native and other interesting things that we care about as Java developers?
Well, lots. So, you can see on the screen there's a lot of pretty icons. You can see, starting from left to right, what are the environments that we're starting to run in? We're starting to run in polyglot environments. And you noticed earlier this week a lot of interesting technology being added to the JVM for interop with C and other languages and native code. You also see these frameworks. We just saw really nice story from a bunch of community members coming together to create an evolution of the Java frameworks into cloud native in a compatible way. And a lot of customers I talk to really want to see that happen. And then we see the new style of programming, which is to create cloud native apps, which are different. Cloud native apps are not just elastic and fault tolerant and all those things. They also dip into a lot of services in the cloud. They're socially aware. They're talking to lots of AI systems and other big data systems. And you're building a kind of a very intelligent app. So that's what's happening, and Java has to respond.
Right, and that puts a lot of pressure on the JVM.
Absolutely.
Right? So look at the kind of infrastructure and the technology that we now are dealing with when we're dealing with the cloud. We've got a whole bunch of new sorts of pressures on the JVM that we never had before. So app platforms like OpenLiberty are starting to integrate not only the servlets, but also the serverless programming, the event-based programming, reactive programming. All these other sort of models of programming are coming in there. And the JVM has to be able to respond to what it sees in terms of the application demands that it puts upon it. And it has to do that kind of autonomously, really. You don't want different types of JVM to be specially designed for these different sort of programming languages. But being a cloud-aware JVM brings those challenges, but also some opportunities. So the challenges are things that I just mentioned. It's the fact that you've got this very varied set of programming models, all of which have got different expectations about what they need from the JVM. You're now also working in a dynamic environment beneath you. So being container-based, working on virtualized systems where you may have a different amount of memory and CPU availability in a very dynamic environment. And also the sort of raw cloud economics, the fact that you're now paying for gigabyte hours of time on the cloud means that you have to be very aware of that in your implementation of the JVM. On the flip side, being in part of that cloud gives you some great opportunities as well. Absolutely. You've now got access to all of these services that the cloud provides for you. And so we can build smarter JVMs that take advantage of that. We've got a much tighter DevOps integration where the developers are deploying to the cloud, they're reprovisioning services, you're getting feedback as to what that service is actually running. And so you have a much tighter loop and better information about what your application is doing. And because of that, the JVM can be a lot more responsive than it has been before.
Okay, so Tim, what are we doing to address these challenges? How are we going to go to the next level, to the next step?
So, as you know, Pratik, we open sourced the J9 JVM at Eclipse. And J9 has got a great pedigree of really efficient memory management, really high performance, of taking care of power consumption in a wide variety of environments. And at Eclipse, we've got a real community who are interested in that innovation in the cloud space and have been able to sort of really derive some vision and some enhancements for that. So Openj9, which is the project name, now it's at Eclipse, has got some wonderful characteristics. We're measuring workload numbers with Openjdk and the Openj9 JVM that show 50% smaller memory footprint at runtime, a massive saving. We're also seeing it ramp up much quicker, 42% faster startup typically, and 3 times faster to reach that peak performance so that the JIT is starting to compile your code very quickly. And that's without compromising any of the performance.
Wow, all this sounds really amazing. A little bit hard to believe, Tim.
It's true.
We can do this.
It's true, but don't just take my word for it. A whole bunch of other people have actually tried running their applications on Eclipse Openj9 with OpenJDK, and they're tweeting about it. They're sharing some of their experiences and seeing that they're seeing a lot of these benefits. People are also really happy to see that we now have a Mac version for JDK 11. So that was a big request, and that's been delivered very recently. And of course, we're using this same sort of technology back in-house inside IBM with our products. So we're not only seeing the sort of improvements in the applications, but we're seeing it on standard industry benchmarks that are using this sort of technology.
I love me some benchmarks.
So the SpecJ Enterprise 2018, you've probably heard, has been enhanced to better represent the types of applications that run in the cloud. It uses the Java EE web profile. It uses the new security. So it's the first time we've had TLS security in a SpecJ Enterprise benchmark. It's sort of based on cloud architecture. It's actually like a simulation of an automotive insurance brokerage application using REST APIs. And it's based on 3 independent microservices, each of which can scale from that. So, very courageously, I guess, IBM has been the first one to publish a SpecJ Enterprise 2018 benchmark score of 601, SpecJ Enterprise 2018 WebJ opt per core, which is the official term for the measurement that you take on those things.
Yeah, Openj9 is great, I heard. So the things we focused on in Openj9 have been cloud-driven. And this is a lot of VM-specific optimization. You've heard me talk before. Small footprint. You've got to be able to both deploy small applications, but also run in light footprint. Fast startup. We have features like cache compilation. I'm going to talk fast because the JIT's fast. But it means that if you create 100 microservices, you bring them all up, they all share underlying cache that can make them come up way quicker. There's container awareness, which is absolutely critical for proper VM behavior in clouds. If you don't respond to the container is going to spank you pretty hard, and that's not a good thing. So Java and Openj9 responds to the container constraints and optimizes. The other one that's little understood is our idle awareness. Lots of you probably who run lots of applications probably know this, but your apps are always idle or frequently idle. And if we can reduce the resource, which we do, during that idleness, you actually get a much more efficient cloud because you're freeing up memory for all the rest of the applications. The last one is the most interesting one to me because as a JVM person, I know every dirty secret of every bad thing you've done in your runtime running on the JVM. And that's a really great piece of information to be able to get back to developers and help them as part of their DevOps process be more efficient.
And that's all great technology.
That's all great technology.
That makes the JVM really sort of start to take advantage of some of the things which are in the cloud.
Yeah, absolutely.
But we need to take it to the next level. We need to take it to the point where the JVM itself is a cloud service and becomes part of the cloud-aware native applications.
I'm sorry, did you say the JVM becomes a cloud service?
Yeah, let me explain how that works, right? So imagine you've got a whole bunch of applications that are running, serving web requests, and you're looking to do that kind of horizontal scalability where you're firing up a whole bunch of new JVMs to service additional requests that are coming in there. You want to do that in a resource-constrained environment because you're paying for that on the cloud, of course. So what we have is a whole bunch of JVMs running exactly the same code servicing these requests. And the first obvious thing that we can do is to take our ahead-of-time compiled code and share that across all of those instances. Right?
Exactly.
So the sort of trivial thing to do is share the ahead-of-time code, which has been compiled to a certain level of efficiency, but doesn't have all of the profile-directed compilation enhancements in there. So it's not the fastest possible code that you can get. You still need to use the JIT to kind of top up from where you were with the AOT cache all the way up to the highest performance. So to make our JVMs web-aware and cloud-aware, the next stage is to start to move those JITs out of the JVM directly. And so the JVMs take advantage of the JIT as a service in the cloud. That gives you two advantages. First of all, you're reducing the size of the JVM. Each JVM is not carrying a JIT with it. And secondly, the JIT can be smarter because it's compiling the code once for your application. No longer does each JVM have to recompile string and class as though it's the first time it's ever seen it. It can now share that across all the instances. So you can pack in more JVMs and have a smarter JIT. And beyond that, the JIT then has access to all of the cloud services, so it can start to use things like artificial intelligence and smart analytics to configure how that JIT is going to work.
Oh, that's really amazing stuff. So how many years do we have to wait until we can start doing all this stuff?
None.
You should invite Mark out to tell you what he's got running.
All right, let's bring out Mark Studley, Openj9 project lead. Mark, come on out. Hello, Mark.
Hi, everybody.
So, did we sacrifice something for the demo gods tonight?
We'll
Let's see how it goes.
Let's see how it goes.
All right.
All right. So I'm really excited to be here today so that I can tell you, for 20 years we've been doing everything we could to put the best JIT compiler technology into the Openj9 JVM. But today I'm here to show a demo of some of the progress we've made from a small group of people who've been trying for the last couple of years to take the JIT out of the Openj9 JVM so that it can operate as an independent cloud service. Now, the demo I'm going to do today has two laptops. On this laptop, I'm going to be running the Acme Air Java EE 7 benchmark, running on top of Open Liberty servers and using Openjdk 8 for class libraries. I'm going to be running a bunch of servers using the same basic CPU and memory envelope. I'm going to give each one 256 megs of memory and half of a physical CPU core. The three configurations that I'm going to run, so that's a very tight, I'm backing the JVMs basically into a corner here. I'm going to run basically three configurations, which mostly differ only in the JVM that's being used. So the orange data, as you can already see on the graphs, is Openjdk using hotspot, and you probably realize it already has a JIT inside it. The blue graph is showing the data using the Openj9 JVM, which has a JIT inside it. And the green data is a special configuration that's going to actually have two Open Liberty servers. But those servers are going to use Openj9 without a JIT inside. They're going to be talking to a remote JIT service that's operating somewhere else. Now, where is this JIT service? It's on this other laptop, and it's going to be, making compile requests as it goes along this network cable, right? So fortunately, I can make method requests a lot faster than I can walk along this cable, and I think I'm going to stop because it's going to take me too long to get here.
Well, you don't want to unplug it by mistake.
That's right. Bad. I don't want to unplug it by mistake and sacrifice my demo. Over here, I'm going to be running a remote JIT service. And it's also going to be running the databases for the applications, and it also has the thing that's going to drive the load. So let me just get the load going after I type my password. And so the load drivers are now starting up, and I can start telling you more about these graphs. So on the screen, you're going to see 4 graphs. On your left, you're going to see at the top the memory that's being consumed by each one of the three configurations. Remember, orange is hotspot, blue is OpenJ9 with a JIT, and green is 2 servers with a remote JIT using the service. On the lower left graph is showing the CPU that's being consumed by the various configurations. And remember, I've used 2 Open Liberty servers in that green data, so don't be surprised that it's going to use a full core worth of CPU. I did this primarily so that I could show that multiple servers can connect to the JIT service and still handle the full ramp-up requirements of the Acme Air application. On the right-hand side graphs, at the top you're going to see the throughput that's being delivered by the various servers in these configurations. And you can see that the OpenJ9 JVM got off to a really fast start. It really ramped up very quickly and handled some load, but it's about to kind of tail off now. You can see that the green data, which is the 2 servers, is just about to, it just did surpass the OpenJ9 server, and it's going to keep going. It's going to keep ramping up. The bottom graph is showing the CPU activity on the JIT server, which is running on this laptop here. Now, the reason why we want to take the JIT compiler out of the JVM process is because of the dynamic resource requirements for the JIT compiler. They interfere with the application server or whatever application trying to do its own work. If we move the JIT out of the process to someplace else, then we can still provide, we're still doing it while the application's running, so we can still provide that amazing speculative and profile-based performance that, let's face it, we've all come to expect from the JVM. But we can do it without sacrificing, any of that performance, which is something that more traditional ahead-of-time compiled code techniques are going to be hard-pressed to deliver by themselves. So I'm not really going to have time to show the full demo, so if we could switch back to the presentation, I can show.
There we go.
Thank you. So this is showing basically a run that I did yesterday for a full 20 minutes. And you can see that across the full range of that 20 minutes, the 2 Open Liberty servers that were running OpenJ9 with the JIT remote service actually provided very good ramp up and a little more than twice the throughput, even though I only gave them twice the CPU resources. And you can see some of those memory spikes. You can see the blue line has a couple of memory spikes and some memory spiking at the beginning, showing that resource contention that's hurting the ability of the JVM to ramp up early. And hotspot is actually the one that shows the CPU contention in its ability to ramp up through the graph. So this is obviously a very simple scenario with 2 JVMs, but you can imagine scenarios where you've got tens or even hundreds of microservices, each one running in a JVM, and each one with its own JIT compiler, trying to compile again and again and again and again the same methods in order to get up and running in your system. With a centralized JIT service or set of JIT services, we can consolidate that work in one place, and then we can begin to optimize it so that we don't have to do many compilations in order to service many JVMs. And on top of that, we can start to employ machine learning techniques and other more aggressive optimization techniques because the dynamic footprint of the resources that the JIT compiler uses are no longer tied to the runtime envelope of the application. The application gets all the cycles and all the memory.
Nice. It's an awesome demo. Thanks, Mark. Appreciate it. All right, so as Mark explained, lighter runtime, less memory utilization, less CPU utilization, perfect for cloud deployments because you save some money, have your stuff run faster, which is great.
It's exactly it. So we're no longer just trying to support the cloud or trying to exploit the cloud. We're actually trying to become part of the cloud. I think this is the future of JIT compilation, native code compilation in the cloud, and I'm really excited that we're on this journey right now.
Awesome.
It's cool.
Thanks, Mark. So next question is where do we get OpenJ9? And what I'd like to do is bring out some of the folks from the Adopt Openjdk project to talk about Adopt Openjdk and where you can get J9 and other hotspots. So, and as we know, it's super important for us as a community to always have Java available freely, open source, secure streams that we can rely on for years and years. And we have Daniel, Tricia, and Simon from the London Java community who are going to talk a little bit about Adopt OpenJDK. Thanks for coming, y'all. Let's give them a hand. Let's give Mark a hand first. Okay. So why don't you tell us what was the genesis or the start of the Adopt OpenJDK program?
So we came up with the idea originally of Adopt.jsr when the London Java community was part of the JCP EC. It still is now, but it was right at the beginning. And we decided that as well as Adopt.jsr, what we wanted was Adopt OpenJDK. The idea was to get developers aware of what the OpenJDK was, how they could participate, what's a JEP, and all the different ways in which they could help to contribute to the evolution of Java. So that's kind of where it came about. As part of that, we were also looking at how to make it easier to build, right? Because it was quite difficult to build the OpenJDK back then. So quite from the beginning, it got quite closely associated with building the OpenJDK as well.
And the way it really came about was that the LJC team that looked to run the community, we used to go to the pub quite a lot. And
I like where this is going.
This is where all good ideas come from. And just a few bottles of wine past the Balmer Peak, I guess. We always used to have some nice red wine, and then Trish used to say some really interesting, exciting things, and we just used to implement them. And so that's how it really came
That's
about.
why whenever these things come up, I always say, that was my idea. I didn't do it. Trish, I just drank something, and then we came up with the idea.
Yeah. So can you tell us more about Adopt OpenJDK and why it's important?
Yeah, I think it's super important that the community has access to builds of OpenJDK. And now Adopt is a bunch of very interesting people like yourselves from the community coming together, working on a build farm so we can continually crank out all the different versions of Java. And we're literally at the moment offering 8, 9, 10, 11 with Amber, and we're also offering OpenJ9 builds, hotspot builds. We really want to be a place where people can come and get the OpenJDK, get a fully ready-to-go binary, and we want to make it as tested as possible. We're always open to contributions, for sure, in terms of from the community, but that's our raison d'etre at the moment.
One of the nice things as well is some of the platforms we build on actually go above and beyond what is typically provided from the Oracle platforms. So, for example, if you're interested in some of the alternate platforms such as AIX, or if you're looking for ARM32 or ARM64, those are some of the platforms which the Adopt OpenJDK builds
and
on
Raspberry
as well.
Pi.
And Raspberry Pi
is super important, yeah. So.
Nice. So, what's being delivered now, and what do we have in the pipeline in terms of Adopt OpenJDK?
So at the moment, the build farm is up and running. It's definitely a work in progress, so we are actively looking for contributions and so forth. But people can pop along. We've got a website you can download the binaries. We've also got an API gateway. You can basically programmatically query and download and get the latest binaries for all the platforms Simon mentioned. We are very much looking for contributions from the community, in particular anyone with DevOps expertise and security in particular. We're looking to make sure the whole infrastructure is as secure as possible. We have solid provenance and governance.
I know someone who has a security company, by the way, now. So,
don't mention it.
Is that JetBrains?
All right. So who's kind of involved in all this activity, aside from the companies and the people? Kind of give us an idea of the scope of the folks involved in this.
Yeah, so one of the nice and interesting things about this project is it's a real community-based project. We have developers, 300-400 developers, all contributing to this project. In terms of our tier one,
did you say 300 or 400?
300 to 400
globally.
Global developers. We also have a number of top-tier sponsors, including, of course, IBM, including Azul, including the LJC, Ocado, Packet. I don't want to miss any. Microsoft, and these sponsors provide us with obviously some money so that we can actually go and buy the actual machines behind the build farm.
So you don't have to run the machines in your bedroom then.
Exactly.
Nice.
Yeah. Exactly. So yeah, in terms of the backing, it's really community backed as well as a number of companies that are sponsoring it as well.
Great. Well, thanks, y'all. Hope everyone check out Adopt OpenJDK. We think it's a great project, and of course, IBM through Eclipse OpenJ9 is a huge contributor to that effort, and we're proud to do that.
And there's certainly the one final thing I'll leave with is that one of our big goals, given everything that's been happening with the talk around the support of Java, is that adopt OpenJDK with the help of communities, including companies like IBM, Red Hat, and the wider community. We are aiming to support the OpenJDK LTSs for 4 years after they have been released. So adopt OpenJDK, I believe, is going to be the place where the community and people can grab free adopt OpenJDK builds with support from the community.
Awesome, yeah.
Can we also subtly plug adoptopenjdk.net?
Adoptopenjdk.net. All right, I got you. Give these folks a great round of applause. Thanks for coming up. Okay. So it's super interesting and kind of amazing what's happening in the Java community, especially today with all the things that Mark talked about, with Adopt OpenJDK, all the different activities in the cloud native space, and how we're weaving together all this other different tech into the Java ecosystem to push the envelope forward. So what I'd like to do at this point very quickly is we have a ton of IBMers who have been speaking at this event. We'd like to bring all of you on up very quickly. We've never done this before, so everyone get up and run onto stage quickly, because we don't want to cut into okay, let's start throwing some socks out. Oh, yeah.